In this tutorial, we will focus on the search pointer function, which is crucial for finding pointers that reference specific values in memory. A pointer, in simple terms, is a memory address that stores the location of another value in memory. This function has 4 parameters. These parameters are filled with values when you provide arguments during a function call. In this case, max offset, memory from, memory to, and limit are the parameters. They are part of the function's definition and describe what kind of data the function needs to operate. Arguments, on the other hand, are the actual values you pass to the function when you call it. When you call the function, you provide values for the parameters, and these values are called arguments. The arguments replace the parameters in the function during execution. The reason we see square brackets is that these parameters do not need to be provided every time you use the function. If you choose not to provide them, the function will automatically use default values. So, the square brackets indicate that these parameters are optional and can be skipped. If not provided, the function will fall back on the default values, making it more flexible and easier to use. Now that we have covered the function syntax and the meaning of square brackets, let's move on to some practical examples. In these examples, we will demonstrate how to use the search pointer function in different scenarios. By testing various cases, we'll gain a deeper understanding of how to use the function effectively and explore its flexibility. In this example, we begin by displaying an alert message, letting the user know that the search is about to start. Next, we use the search number function. This searches for the value 100 in memory, specifically looking for it as a D-word type. Sign equal means we are looking for an exact match to the value 100. The 0 and -1 indicate the range of memory to search, starting from address 0 and searching all the way to the end of the memory. After the search, we use getResultsCount function to get the number of results found, and store that count in the variable count1. Finally, we display another alert, which will show the user how many results were found during the search. Now, we move on to the second part of the search, where we search for pointers referencing the results from the first search. We start by displaying an alert to let the user know that the pointer search is starting. Next, we use the function searchPointer. This search looks for pointers with an offset of 1024. It will search through the results from the previous search to find pointers that point to those results. After the pointer search, we use getResultsCount function to get the number of pointer results found, which is stored in the variable count2. Finally, we display another alert, letting the user know how many pointers were found in the search. In this example, we are searching for a value within a specific range of memory. We first define the starting and ending memory addresses. Next, we clear any previous search results with clearResults function to ensure we are starting fresh. We then display an alert, letting the user know that the search is starting. Now, we perform the search using searchNumber function. We are looking for the value 2.0 as a float. The search is constrained to the memory range between start address and end address. After the search, we retrieve the number of results with getResultsCount and store the count in the variable count3. Next, we display another alert, which informs the user how many results were found in the specified memory range. We then perform a pointer search with searchPointer function, searching for pointers referencing the found value 2.0 within the same memory range. After the pointer search, we again use getResultsCount to retrieve the number of pointer results and store that count in the variable count4. Finally, we display an alert, letting the user know how many pointer results were found in the given range. Note: the values used in the search pointer function depend on each specific case. In this example, we are using a memory range defined by start address and end address. This range specifies where the search will take place, looking for pointers within the addresses between those two values. However, in other cases, you might use direct values instead of a range. These direct values would correspond to actual byte offsets in memory. For instance, instead of a range, you might use an offset value like 1024 or 2048 to look for pointers within that specific number of bytes from the current memory address. So, depending on your use case, you may either define a range of memory to search or use direct byte offsets, adjusting the values accordingly. In this example, we are working with specific memory addresses. We first define the addresses we want to search. This creates a table of specific memory addresses. Next, we display an alert to notify the user that we are loading these specific addresses. We then use load results to load these specific addresses into the search results. After loading the results, we perform a pointer search with search pointer, which looks for pointers within an offset of 512 bytes from the loaded addresses. We retrieve the number of pointer results found with getResultsCount and store that in the variable count5. Finally, we display an alert to inform the user how many pointer results were found for the specified addresses. Note, since these addresses are not verified, the search will return 0 results. The addresses used in this example do not actually exist in the current memory being tested. Because of this, when we attempt to load them and search for pointers, the result count will be 0. This highlights the importance of checking and confirming that the addresses you are working with actually exist in memory before performing a pointer search. In this final example, we are performing a value search with a result limit. We start by clearing any previous search results, ensuring that we begin with a clean search. Next, we display an alert, informing the user that we are searching for the number 9999. We then call the search number function, which searches for the value 9999 in D-word format across the entire memory range. After the search is complete, we retrieve the number of results using getResultsCount and store that count in count6. We then display the result count with an alert. Now, we proceed to the pointer search using the search pointer function. The first value, 1024, defines the maximum offset for the pointer search. The range remains from 0 to -1, meaning we are scanning the entire memory. The last value, 10, is the limit on the number of results. This ensures that only up to 10 pointer results will be returned. Once the pointer search is done, we again retrieve the number of results with getResultsCount and store it in count7. We then display the results with an alert, informing the user how many pointers were found within the set limit. Finally, we display a completion message, confirming that all searches in the tutorial have been executed. That concludes our exploration of the search pointer function. We have covered its syntax, key parameters, and how it works in different scenarios. From searching for values to identifying pointers within specific memory ranges, we have seen how this function can be a powerful tool for memory analysis and modification. Remember, the values you use in search pointer, such as offsets, memory ranges, and limits, depend on your specific case. Understanding how to adjust these parameters will help you get the most accurate and useful results. With practice, you will be able to fine-tune your searches and use this function effectively.